Hello everyone, welcome back to our channel. If you've been following along, you've just unlocked the power of network automation tools in our previous video. Today, we're diving even deeper into the world of networking with our brand new series, Python Mastery for Network Automation and Programmability. Before we dive in, let me assure you that if you've missed any of our previous videos, there's no need to fret. I've got you covered. I've provided links to all 4 of them below, so you can catch up at your own pace. Rest assured, you're in the perfect spot to embark on this exciting journey with us. Now, let's jump right in. Alright, let's kick things off with a bang by introducing Python and understanding why it's a game changer for network professionals like you. Python isn't just another programming language. It's a versatile tool that empowers you to automate network tasks and take control of network management like never before. To put it in perspective, think of Python as the Swiss Army knife of networking. Just like how a Swiss Army knife has various tools for different tasks, Python equips you with a range of capabilities to tackle network challenges efficiently. Now, let's dive into the exceptional advantages of mastering Python for network automation and programmability. Imagine Python as your ultimate tool, your digital Swiss Army knife tailored for a networking landscape. But you might be wondering, is Python the only programming language suitable for network automation? Can we use Java, C++, C#, or other languages? Great questions. While it's true, the various programming languages can be used for network automation and programmability, Python stands out for several compelling reasons. Let me break it down for you. Versatility and ease of learning. Python boasts a simple and intuitive syntax that's easy to understand and learn. This makes it an excellent choice for beginners and seasoned professionals alike. Its versatility shines through as it covers a wide range of applications beyond just network automation, including web development, data analysis, and more. Rich ecosystems of libraries and frameworks. Pythons offer a vast ecosystem of libraries and frameworks specifically designed for network-related tasks. Modules like Paramiko, Netmiko, and Napalm simplify network device interaction. And of course, frameworks like Ansible, Narnia, and Robot Framework provide powerful automation capabilities. Community and resources. Python has a thriving and supportive community. This means you'll find an abundance of tutorials, forums, and resources to aid your learning journey. The Python community's collaborative spirit ensures that you're never alone when facing challenging or seeking advice. Industry adoption and integration. Python's popularity within the networking and DevOps communities is undeniable. Major companies and organizations have embraced Python for automating their network infrastructure, making it a sought-after skill in the job market. Ease of integration. Python seamlessly integrates with other technologies and tools, allowing you to build comprehensive automation solutions. Whether it's integrating with APIs, databases, or other systems, Python's flexibility empowers you to create cohesive workflows. So, while other languages certainly have their merits, Python's combination of versatility, community support, and industry relevance make it a top choice for network automation and programmability. Starting your journey with Python provides a strong foundation that can lead to mastering other languages if you choose to explore them. With Python, you're not just learning a programming language, you're adopting a skill that can transform your approach to network management and automation. Why start with Python before diving into other network automation tools? You may ask. Well, Python acts as your foundation, your building block. It's the language that forms the backbone of various automation frameworks and tools. By mastering Python first, you're not just learning a programming language, you're building robust groundwork for your automation journey. So let's explore how Python versatility and power will reshape your approach to network management and automation. But here's the exciting part. This video series is crafted with you in mind. Every example, every concept we cover is tailored to the needs of network experts like you. We're diving into Python's wonders in a way that resonates with your networking background. Now, with this explanation in mind, are you ready to get hands-on? Great! Let's start by installing Python. Don't worry, it's a straightforward process that I'll guide you through step by step. Great! If you watched the video up to this point and enjoy it, I kindly ask you to like the video. Liking it would help this video reach more people, individuals like yourself who are interested in these topics. Also, if you don't want to miss out on future tutorials, I recommend subscribing to our channel. This way, after I upload a new video, you'll be notified through notifications. Okay, first of all, let's see how you can install Python in your machine. Alright, the first thing you need to do is go to the Python website at python.org. That's the official Python website. From there, click on the download link and get the latest stable version. Please keep in mind, I'm using a Windows operating system, so I'll be downloading the Windows version. If you are on Mac OS or other platforms, you should go to the respective links and download your preferred version. If you're using Windows like me, simply click on this button. Awesome! The download is finished. Now, let's get it installed. Installing Python is super easy, just like other programs. Simply follow the installation steps. Just one important note. Remember to check the Add Python to Path box. This ensures Python is available from anywhere. In other words, you won't have to go to its installation location to run it. It will be runnable from anywhere. Now, select the Install Now option and let the magic happen. Now that Python is installed, are you ready to take a look at it? Great. Let's see how we can make sure Python is correctly installed and also check its version. To do that, follow these steps. Open the command prompt if you're on Windows, or terminal if you're on Mac OS or Linux, and then type Python --version and press enter. This will display the version of Python installed on your system. If you see the version number, it means Python is installed and working properly. Sounds good. Now that we are sure Python is installed correctly, let's take a quick look at the tools available for writing code. We have a few options to explore. First, there's the Python console. Second, there's IDLE. Third, there's a text editor. And fourth, an IDE. Let's go through each of these options briefly. To start off, let's begin with the Python console. The Python console is a simple tool for coding in Python. It's often used to test code snippets or for general prototyping. Writing and editing long codes in this workspace might not be very comfortable. Well, let me show you what this environment looks like and how to use it. To access the Python console, simply type Python in the command prompt or terminal if you're on Mac OS or Linux, and hit enter. Now, the Python console is ready to take your commands or codes. Let's say you want to calculate the sum of two numbers. On the Python console, you can easily type number 1 equals 5, number 2 or num2 equals 10. The result equals number 1 plus number 2. And finally, let's ask, hi Python, what is in the result? And incredibly quickly, Python shows us the number 15 in the result. All right. Now you might be wondering what are number 1, number 2, and the result. We call these variables. They hold different values of any type. For now, let's just imagine each of them as a container with something inside. Don't worry at all. In the upcoming videos, we'll get fully acquainted with the structure and how to interact with Python. Now, let me show you something. In this example, I could have done this in Python console without even using these variables. I could simply type 5 plus 10 and quickly get the same result. This is to say that the environment is perfect to testing code snippet and prototyping. If you want to exit this environment, simply type exit or quit with parentheses around them. Alright, let's now get a brief introduction to the IDLE environment and type the same code there to see the result. But first, let me provide a quick explanation about IDLE. As you can see, the Python console is very simple and basic, lacking the necessary tools and features for easier and better code writing. For writing code, we need an environment that lets us easily write, edit, and even debug our code. It would be great if that environment could guide us along the way, remind us of certain points, and offer various helpful capabilities to write, run, and manage our code more efficiently. Such an environment is called an Integrated Development Environment, or IDE. When you install Python on Windows or Mac OS, it comes bundled with its own IDE called IDLE, which stands for Integrated Development and Learning Environment. If you're using Linux, you can download and install it through your package manager. One more thing to note is that IDLE has fewer features compared to more well-known IDEs, making it a great fit for beginners. As we delve further into this topic, we'll become more familiar with the necessary features and IDEs. Alright, with this explanation in mind, let's move on to IDLE and type the same code there. There are different ways to access IDLE, just like other programs. One simple way is to type IDLE in the search box on the taskbar and click on it. Great. IDLE is open now. As you can see, it starts with the Python console. Here, I'll type 5 plus 10 and hit enter, and the result will be displayed. But if we want to make use of its features, we need to first create a file through the File menu. Now, we can write the same code here. I recommend saving the file with your desired name before writing the code. Since Python files are saved with the .py extension, IDLE can help you write code by suggesting and guiding you along the way. Perfect. I'll save the file as addition.py. Now, once again, number 1 equals 5, number 2 or num2 equals 10. The result equals number 1 plus number 2. And I'm adding a new thing, print result. Since I'm not in the console environment, I need to use the print function to call this variable. Don't worry. As I mentioned, we'll become familiar with the structure and how to interact with Python in the upcoming videos. Here I'm just giving you a brief overview of Python and the tools we have for code writing. That's it. Now, take a look here. The print command is highlighted in a different color. This indicates that this command or function belongs to Python. For instance, if I hold down the Shift key after typing print and an open parentheses, ideally will guide me on what things I can write in this function. Of course, this is just a small part of the features of an IDE. Alright, let's execute the code. Simply choose Run Module from the Run menu or press the F5 key on your keyboard, and our code is executed, and we get the same result once again. Let's move on to the next option, which is a text editor. Another tool we have for Python coding is text editor. It doesn't really matter which one you use, such as Sublime, Atom, Notepad++, or any other text editor. Just save your code file with the .py extension and then run it using the command prompt or terminal. If you are inclined towards minimalism, a simple text editor could be sufficient for you. In that case, I recommend looking into text editors that offer more features and capabilities in this field, like Sublime Text. Alright, now let's see how we can type and run our code in a text editor. I'll be using Sublime here. Again, I suggest saving your file with the .py extension first and then typing or copying your code. Let me start by saving the file as addition1.py. Okay, great. Now, once again, number 1 equals 5, number 2 or num2 equals 10. The result equals number 1 plus number 2, and in the end, just like what we did in ideally, we'll use the print function to call the result variable and display its content in the output. Since I saved the file with the Python format and Sublime Text supported, you'll notice that it provides some features like auto-completion to make code writing easier. Also, as you can see, it uses different color to distinguish between Python functions, variables, and values. Fantastic! I'll save the file again, and now let's run it using the command prompt. Remember, when you are in a code editor, we usually use the command prompt or terminal to run it. Why do I say usually? Because there's an exception. For example, in Sublime Text, you can use Ctrl+B to execute the code. Look, the code ran and we got the same result of 15. But keep in mind, this method doesn't always work. For instance, when your code needs to perform actions on a specific device, this method might not be effective, and you'd have to resort to the command prompt or terminal. Alright, let me open the command prompt by using the change directory command or cd to navigate to the directory where my file is saved. I've saved the file in a directory named Autopynet on my desktop. So I'll type cd desktop /Autopynet, and now I'm inside the Autopynet directory. Now I can type Python space addition1.py, which tells Python to execute the addition1.py file for me. And again, it's displayed the result of 15 in the output, as you can see. Well, there's an even simpler way to find the file location. Just navigate to the folder where your file is, and in the address bar directly type cmd. This will open the command prompt in that directory. As you can see, it's displaying the folder address I'm in. Here I'll type python addition1.py and my code is executed. It's that simple. Alright, now it's time to get acquainted with an environment and a comprehensive tool for your work, which is the Integrated Development Environment, or IDE. As I mentioned, an IDE is a complete tool that allows us to write, execute, and manage code. It not only provides features like IntelliSense, which includes various code editing features like code completion, parameter info, quick info, member list, and more to help us write code faster and accurately, but it also enables us to manage projects and solutions. Let me briefly explain. In simple terms, my friends, a project can consist of multiple files, and a solution can be composed of several projects. It can assist us in managing database communications and much more useful and practical tasks that we'll become familiar with as we continue our discussions. Alright, one of the IDEs we'll be working with extensively throughout this course is a lightweight yet appealing one called Visual Studio Code, or VS Code for short. In this video, we'll just take a glance at it and run a couple of simple codes in it. The more we proceed in this topic, the more we'll become familiar with the features and capabilities. Now, if you don't have it on your computer, head over to code.visualstudio.com and download it from there. If you're using Linux or macOS, simply click on this small button and select the version you need. Then download it. After that, just follow the installation steps like you would with any other program to easily install it. Well, I've done this before. Alright, before we start, there's a small task you need to complete. You should go ahead and install the Python extension. By doing this, you'll activate Python IntelliSense and you can make use of the features I mentioned. To do this, go to the File menu, then select the Preferences submenu and choose Extensions. In the left panel of this Extensions panel, find and select the Python extension to install it. If you don't see the Python extension here, just type Python in the search box to locate it and then install it. Let's write the addition example in VS Code and run it. The first step is to create a Python file. To do this, go to the File menu, select the New File option, and then choose Python file. Now we have a Python file and we can copy our code into it. Keep in mind that since we installed the Python extension, you'll notice some of the IntelliSense features kicking in as I start typing. Alright, once again, num1 equals 5, num2 equals 10, the result equals number 1 plus number 2 or num2. Just like the previous example, we'll use the print command or function to call the result variable and see its content in the output. As you can see, different parts of this code like variables, values, Python functions, etc. are color-coded for clearer differentiation. Of course, I should mention that you can customize these colors to your preference later. And here's another interesting point. Notice what happens when I hover my mouse over different sections of the code. When I hover over variable, their value are displayed. Here, hovering over the result variable shows me the sum of number 1 and number 2. Or here, if hover over the print function, it gives me a brief explanation of the function and how to use it. It is fantastic. I'm sure you'll agree with me that these features really help us write code more effectively, accurately, and quickly. Alright, now let's execute our code. To do this, select the Run Python File option from the upper right corner. Since we haven't saved the file yet, VS Code will prompt us to save it in our desired location. Let's name it Addition to and save it in the same Autopynet folder. As soon as we save it, you'll see the result 15 displayed at the bottom of the page. And now that I've saved the file, every time I select the Run Python File option, our code will be executed. Alright, here's another point to keep in mind. Each of this environment has its unique strength to cater to different needs and scenarios. Ultimately, the choose between them depends on your requirements and the work conditions you have. And remember, there are other highly capable and professional IDEs available, such as PyCharm, IntelliJ IDEA, and so on, that you can use to take advantage of their capabilities for efficient and optimized coding. I suggest exploring those options too and selecting the one that suits your need and style. Well, up to this point, we've gotten somewhat familiar with the basics of stepping into the world of Python for networking. If you're not already acquainted with Python, don't worry at all. We are just warming up. In the upcoming videos, we'll delve into the building block of Python and systematically explore everything in a specialized manner tailored for network experts like yourself. I promise you'll fall in love with it. Before we wrap up this video, let's tackle a very simple example related to our topic at hand, which is network automation and programmability. Once again, I want to reassure you not to worry at all. In the upcoming videos, we'll delve into the core concept of Python in detail. Right now, my intention is to give you a general overview so that you can feel comfortable and friendly with the whole subject and Python itself. That's it. Alright, let's do this. Allow me to create a script for checking the availability of network devices by pinging them. Through this example, I aim to show you 3 key points. Firstly, how straightforward it is to interact with Python. Secondly, how easily we can perform network management tasks with flexibility using Python. And thirdly, how Python can enhance our creativity for better and more precise tasks. So, let's get started. But before anything else, I need a few devices to ping and check their availability. Where can I get these devices? Well, these devices can be anywhere. They could be network devices, servers, or even PCs located within my network or somewhere on the internet. Alternatively, I can use simulators like GNS3, EVE-NG, Cisco CML, or Cisco Sandboxes. For now, it doesn't matter what these devices are or where they are. For this example, I'm using GNS3. Here are my devices in GNS3. As you can see, I have 3 routers. 2 of them are powered on and 1 is turned off. Now, I want to use a simple Python script to ping these devices and check their availability. To connect my laptop to GNS3, I'm using a cloud and creating a loopback network card in Windows connected to this cloud. I've assigned an IP address in the router's range to this loopback network card. As you can see, it's 10.12.1.254, and I've assigned an IP address to each of my routers as well. It's simple and easy. Look, my friends, if you're not familiar with GNS3 now, or haven't worked with GNS3 or the simulators I mentioned before, or don't know how to connect your computer to them, don't worry at all. When the time comes, I'll create a complete video about setting up your lab, guiding you step by step. In the meantime, if you're interested, you can search for a guide on how to install and configure GNS3 or other simulators I mentioned. As I mentioned in this video, we are just getting a little familiar with Python and some of the tools we need for this course to make you more comfortable with them later on. So there's no need to worry. Now, let's see if I can establish a connection with the routers in GNS3. I just need to ping them to make sure. Let's ping 10.12.1.1. which is the first one, and pinging 10.12.1.2, the second one. And for the third one, which is turned off, let's pinging 10.12.1.3, and the results are clear. Great. Now that we know where our devices are, the next step is to choose a platform for writing our script. Let's move on to VS Code and create a Python file named anything you want, doesn't matter for now, and save it. Excellent. Now let's get into writing our code. You know, writing code is somewhat like cooking. First, you decide what dish you want to make, then you gather the ingredients, and afterward you follow a specific method to combine, cook, and finally serve the dish. And then enjoy it. Somewhat similar here. Now that we know what we want to do, we need to prepare the initial ingredients and place them on the table. Alright. I want to ping my devices from my computer. Therefore, Python needs to communicate with my operating system and execute the ping command. For this task, I'm using a widely used and built-in Python module called OS, designed for interacting with the operating system. I simply call it by importing it with the import command and have it ready to the table. Now, before we're moving forward, let's write a comment for our code so that in future references, we or others can understand what this code is written for. In Python, we use the hash sign to write comments. This way, Python understands that this line shouldn't be executed, and it's just a comment. Alright, now I need to introduce my devices to Python so that using the OS module, it can ping them. To introduce my devices to Python, I'm using a list here containing the IP addresses of my devices, like this. Open and close brackets, and then for each element of the list, which are the IP addresses of the routers here, I write them inside single or double quotes, separated by commas. So, it looked like this. In double quote, I write 10.12.1.1, comma, next one, 10.12.1.2, and last one, 10.12.1.3. Now, to make it easier to use this list later on and call it in different places, I assign it to a variable. As I mentioned, let's consider variable as containers for now. So, I create a variable named, let's say, devices underscore 2 underscore monitor, and use the equal sign to assign the list to it. Alright, to enable Python to read the items inside this list and execute a ping command for each of them, we need a loop that can iterate through the list items. For each iteration, it should perform the desired action. For this task, we use a for loop and type for device and devices to monitor, then place a colon at the end. Pay attention to IntelliSense features. The color differentiation for different part of the code, such as keywords, variables, auto-completion, and etc. This colon we put at the end signifies that anything I write in the next code block should be repeated a certain number of times. In this example, how many times? Exactly as many items as there are in the list. Notice, here I used a temporary variable named device. It doesn't matter what its name is. You can give it any name you like. With this, the for loop in each iteration places one of the list items in the device variable. I can then use this device variable in various parts of the code and call it according to my needs to perform an action on it. Do you see how straightforward Python's syntax is? It's quite similar to human language. Alright. Now, for each item inside the list and in each iteration of the loop, what does Python need to do? Well, it's clear that using the OS module, Python should tell the operating system that for each time, in each iteration of the for loop on the list, execute the ping command once. So, after the colon, I hit enter. And move to the next line. Pay attention. The next line starts with an indentation. This signifies that from here onward, anything I write is inside the for loop and will be repeated for each iteration. Indentations in Python syntax are crucial. They essentially block our code and give it structure. I'll explain this more later. Alright. Now Python needs to instruct the operating system to ping the IP address stored in the device variable for each iteration. Like this. os.system. Notice that as soon as I type os dot, a list of attributes of the OS module opens up for me. I can browse through this list and choose what I want. This is thanks to IntelliSense. Much like when, for example, in Cisco devices, after typing a command, typing a question mark shows you a list of commands you can enter next. Here, I want to use the system attributes of the OS module. So, I type os.system, open and close parentheses, and inside single or double quotes, I type the ping command and create a space. In Python, we write text string in single or double quotes. Don't worry, I'll explain this further later. Now, what does Python need to ping? Exactly, the value in the device variable for each iteration. So I type plus device after this. Alright, if I were to type this command in a command prompt or terminal, if I were to say ping 10.12.1.1, what would I expect to see? Ideally, a reply indicating that our connection is established. Or, depending on the circumstances, replies like timeout are unreachable, implying that the connection isn't successful. In this example, I want Python to tell me for each device pinged, if I receive an echo reply, display this device is up and running in the output. Otherwise, if there's no echo reply, show this device is down. For this task, Python needs to store the received message somewhere and tell me the device's status based on that. So I need to store the messages in a variable or a container for later use. As a result, I must assign the os.system command and what I wrote within it to a variable. Let's do this. I'll create a variable named response. Again, it doesn't matter what the name is. You can choose any name you like. Before os.system, I'll type response equals with this, the os system commands and it contents, which is basically pinging each device, and the reply received will be stored in the response variable. Now, I can use this variable for the next part of my code. Okay. Now, we want Python to determine if the received message is an echo reply, meaning our connection is established. If it's a reply, we want Python to write the device's IP in the output and tell us that the device IP is up and running. Otherwise, if it's not an echo reply, Python should write the device's IP in the output and indicate that the device is down. To achieve this, we need a condition that we write using if. It goes like this. If response equals 0, colon, pay attention, after the colon, when I hit enter and move to the next line, another indentation is created. This means that from this point on, whatever I write is within the if condition. In the next line, I type parent device, comma, double quote, is up and running. And in the following line, I want Python to tell me if the received message isn't an echo reply, that the device is down. First, I need to exit the if condition because I want to check another situation. So I remove the indentation to align with the if statement and use else to tell that the device is down. In the else block, I type parent device, comma, double quote, is down. Okay? I know. You might be wondering, what does that 0 mean? Why should the message up and running be printed if the response equals 0? Let me explain. In this example, Python is communicating with the operating system using the OS module and its features. When I execute this code, Python asks the operating system to ping the devices, right? But have you ever thought about how the operating system understands what message to show you? In other words, how does it know when to return an echo reply and when, for instance, to return a destination unreachable message? Well, All of these are defined within standards for operating systems. Essentially, the operating system recognizes parameters of the ICMP protocol. In the world of ICMP, code 0 means echo reply and code 3 means destination unreachable. To better understand, let's take a look at the ICMP type numbers section on the IANA websites. Okay, as you can see under ICMP type numbers and its subsection code fields, you can find that type 0 or code 0 signifies echo reply and code 3 signifies destination unreachable. So based on this codes defined for it, the operating systems show us a human readable message. And since we've used the OS module in Python to communicate with the operating system, here type code 0 for ICMP is also understandable for Python, representing echo reply. So when I say if response equals 0, I mean that if the code 0 is in the response variable, which is equivalent to type code 0 in ICMP, then in the output, display the message up and running. Otherwise, if any code other than 0 is received, display the message device is down. Now, let's run our script. I'll select the Run Python file option from the upper right corner, and as you can see, our code has been executed successfully. The first router pings, receives an echo reply, and displays the device is up and running. The second router does the same. As for the third router, which is turn off, I receive a timeout message indicating that a code other than 0 has been received, okay? And thus, the message device is down is displayed. That's how easy it is. Okay, let me quickly mention a point. If you don't have a GNS tree or a network device at hand and want to test this code, you can easily replace the IP addresses in the list with a public IP like 111 and even your computer's loopback address, which is 127.0.0.1, or any other IP you have available or not. Change it and run the code to see the result. Hold on a moment. Imagine if we didn't have the OS module. What would we have to do? We'd first need to create a program for Python to establish communication with the operating system. Only then could we write this simplest script. In that case, our task would be much more challenging. Wouldn't you agree? Consider this analogy. Imagine you need tomatoes for a dish. You could easily take tomatoes from the fridge and add them to your meal, or at most buy tomatoes from a store. But if you had to grow the tomatoes yourself, plant the seeds, water them, take care of them, wait for them to ripen, and then harvest them, and only then use them in your dish, it would be quite a task, right? The good news is that there are hundreds, even thousands of ready-made modules like the OS module for various tasks, including automation and programmability. We can effortlessly utilize this module for our tasks. Now, you understand what Python is the most suitable language for automation and programmability, right? It's easy to learn, loaded with efficient modules for diverse tasks, and has numerous other advantages that we'll explore further in this discussion. Hey, I know you might be thinking, I know what Python is. Why bother with all this? Alright, it's true that Python is great, but why go through all this trouble for a simple task like this? Well, you might say, I can easily ping my devices with a single command in the operating system. And sure, there are monitoring software out there to check a device's health. That's a good question. But hold on a moment. Don't rush. Yes, you can definitely do this manually and much more simply. But think about the big picture. Python isn't meant to just handle tasks as straightforward as this one. Python is designed to simplify processes for us, allowing us to make better use of our time, reduce human errors, and create an efficient and stable network. It helps us face today's challenges with complete witness and tackle tomorrow's obstacles confidently. We can approach our tasks creatively and manage our network in a way that match our needs and business requirements. Consider this. If you had to manage a large network with, say, 100 or even 1,000 devices, Python would equip you with a wide range of capabilities. Its limitless features allow you to become exceptional in this field. Just think about this simple code. If you take a creative perspective, you can expand it in a way that cover a multitude of scenarios and features. This might be scenarios that can't be done manually, or even if they could, would be incredibly complex. Okay? Or, for instance, you could extend it and add functionalities that many monitoring software might lack, or at least wouldn't allow you to use as effortlessly. Just take a look ahead and think creatively, and you'll realize how Python empowers us with incredible possibilities. Well, my friends, our journey has just begun. In the upcoming videos, we'll take step by step into the heart of Python, and you'll see how Python will excellently cater to your needs in the world of networking, seamlessly integrating with your network. Keep this curiosity alive. We're on the verge of entering the realm of automation and programmability using Python. Okay, well, thank you for watching this video. If you found it helpful, please like and subscribe. To stay informed about upcoming videos, make sure to turn on notifications.